Hello everyone, I would like to present my thesis work, which is using Monte Carlo tree search for optimizing traffic light phases. So these are the topics that I will be going over. So given a road network which includes the location, speed, trajectory of cars, and the current traffic light states, we want to find an optimal time for the next traffic light phase. And by doing so, we want to maximize a traffic-related criteria, in this case, travel distance of cars. So we're formulating the problem as a single-player game, where the game states are the road network, car positions, and the current traffic light states. Moves would be the list of possible timings for the next traffic light phase, and the optimizer is the player, in our case is the MCTS, along with the traffic simulations. So the idea is to use Monte Carlo tree search that takes in state of the network and maintains a tree whose edges are possible timing sequence. Then we traverse down the tree until we reach a leaf node, and then we do random rollouts. The random rollout simulations are done on Sumo. Once we reach the terminal state, the result of the terminal state is backpropagated up the tree. After doing this multiple times, we choose the most visited edge from the route, and the value of the edge is used as the timing for the next simulation. So over here we have a simple network with two junctions. Junction 1 is in yellow phase, so we want to find the optimal timing for the next green phase. On the right, we can see that the root node starts with junction 1, and when we expand it, we get 10, 15, and 20 seconds. Let us take the 10 seconds, and since that's a leaf node, we do rollout for 100 seconds. This returns us a value of 3 km, which is the average distance traveled by the cars, and this is backpropagated up the tree. Next, we will go down to 15 seconds and then do the same thing. So after doing it for all three edges, we can see that the cost metrics for each edge is 3, 1, and 2 respectively. So we'll travel down the 10 seconds edge as it has the highest cost metric. And then we see that it has, when we expand it, it has one edge. Why is that? Because the next phase after the green phase would be a yellow phase, and we're taking that the yellow phase has a constant time of 5 seconds. So we do rollout again, and it returns us another cost metric. Let's say it's 1 km, and that is propagated up the tree. So the next selected edge would be the 20 seconds, and we go down the tree for the 20-second edge and then expand it and then do rollout again. After that, we choose the 10-second edge since it has the highest cost metric. So we traverse down the tree and then we expand again, and then we'll be doing rollouts again. So we do this n number of times, and when the search stops, we choose the edge that has the highest cost metric. So the current state is that we have implemented MCTS for a simple game like tic-tac-toe, and we're using TrackEye to control Sumo simulations, like adding vehicles, changing traffic light phases, and saving the network and traffic light states whenever needed. And we were able to integrate MCTS with Sumo. We have also parallelized our MCTS since the simulations are a bit slow, so we want to parallelize the rollouts. So we have a server that queries the Sumo environment, which contains the MCTS tree, and then it generates move list by traversing down the tree. This move list is sent to workers, and the workers do rollouts and send back the results, which is then used to update the tree. So for future work, we will be improving our search by fine-tuning the MCTS parameters, adding more performance metrics like carbon dioxide emission, fuel consumptions, and we will also train a neural network for our rollout policies. We'll also incorporate more features into our network like LRT movements, pedestrian movements, and take green wave into account. In summary, we're trying to build an online traffic system that takes in current car, LRT, and traffic light states and outputs an optimal traffic light timing for the next state. And we're doing this by using MCTS as our search algorithm and Sumo for the simulations. I would like to thank ACI for funding this project. And thank you for listening. If you have any questions, feel free to ask.